If you're going to use sensors, industrial sensors, it's a good idea to get familiar with the sensor before you use it. Here's a capacitive sensor, and this is a PNP type sensor, as you can see there. And the number 1 through 25 millimeter below is just telling you the distance, the sensing distance that it's capable of. There's a adjustment screw on the bottom, and there's a light that shows you when the sensor is on, and I'll show you in a second how that works. Also, there's a little diagram here that shows you how to hook it up. So you apply your positive voltage to the positive input of the sensor, and I'll tell you in a minute what that is, because this doesn't really tell you anything about the color coding. And your load, or the thing that the sensor is going to be hooked to, it could be a syncing input, is the little symbol there with the square symbol with a slash through it, and then your negative goes to the bottom terminal of the sensor. Now the color coding for the sensor is it's a little unconventional compared to other things in electronics, but in sensors, our brown wire is our positive, our blue wire is the negative, and our output signal is the black wire. So one way to just tell what's going on with the sensor and get familiar with it is just to hook it up to a 9-volt battery. Some sensors will work well with this, and others won't. So if you don't get any response from 9 volts, then you'll probably have to use a 24-volt power supply, or a voltage that's more appropriate for the sensor. So I'm going to hook this up. The brown terminal is going to the positive terminal, and the blue terminal is going to negative. Now what I should be able to do is get the sensor light to come on when I get it close to an object, as you can see down below. Okay, now all that indicator light is telling us is that the sensor is actually actuated. Now to get the signal out of the black wire, we've got to hook it up a certain way. Since this is a PNP sensor, the output has to be between the black wire and ground, because this is what we call a sourcing sensor. Sourcing means that when the sensor is activated, and you can see it's on right now because of my hand, it's sensing my hand. But sourcing means that when the sensor is actuated, it completes the path to V+. And syncing means the opposite. The sensor completes the path to ground, or V-. And a lot of times people get ground and V- confused. For the most part with sensors, ground is minus, but don't get the idea that ground is always minus. It doesn't have to be, and we'll talk about that in later lectures. So the next thing we'll do is we'll hook this up to a external LED, and we'll see what it does. Okay, we're going to hook the sensor up to see how it supplies current to a load, and I'm just going to use a small incandescent bulb just because it's easy to interface to. An LED is nice, but you have to have a current limiting resistor for that. This is real quick and easy, and it's fairly bright so you can see what's going on. So anyway, I've got these two leads hooked to the incandescent bulb. First thing we're going to do, though, is we're going to take our battery here, a 9-volt battery, and I've got the red lead hooked to plus and the green lead hooked to minus on the battery. So the red lead's going to go to my brown wire. The green lead is going to go to my blue wire. Don't go to black. That's easy to do because most of the time we identify black with negative, but that's not the case with sensors. Also, be careful because not all sensors have a color code that makes sense. For the most part, you'll see brown, blue, and black, or brown, blue, and white, if it's depending on the type of sensor it is. But what you see most of the time for a 3-wire sensor is brown, blue, and black. Okay, so I've got this hooked up, to power. And so if I take the sensor and I put it down on the table, it's sensing the tabletop, or I can have it sense my hand. Notice if I even grab it on the sides, it goes off. These capacitive sensors are pretty sensitive that way. Okay, so that's indicator lights telling me that the sensor is actually activated. Okay, so it's activated, but we're not driving anything yet with it. So let's hook up our load. And before I do that, let me go back to this diagram here on the sensor. This particular sensor has some information here that's useful. The current carrying capability for the sensor is 300 milliamps, and it tells you that the capability, the voltage capability for the sensor is 6 volts to 30 volts, and you may be able to see that or not. It's not coming in real clear here, but there you go. So it's 6 volts to 36 volts at 300 milliamps. Turns out my lamp is going to draw about half that, so we're safe. Okay, so now I'm going to hook up the sensor to the lamp, and so the way I do that is, remember, this is a sourcing sensor, so we're going to hook the black terminal to one of the leads, and because it's sourcing, we want the other lead to go to ground. So once I do that, I have a path, a possible path when the sensor's actuated, so let's go ahead and actuate it. And there we go, we've got a complete circuit. The sensor switch, the PNP switch in the sensor, is allowing the positive voltage from the battery to reach the load, go through the load into ground when I activate the sensor. Now you can have normally open sensors like this, in which the switch closes when you activate the sensor, but you can also have normally closed sensors that open the switch when you activate the sensor. So you have to be careful about, when you're ordering a sensor, that you order it with the right characteristics. In reality, it doesn't matter what kind of sensor you're using. If you're going to hook it up to a PLC, you can get any kind of behavior you want through the PLC programming. So whether you have a normally closed or normally open sensor, it doesn't really matter. But it does matter if your piece of equipment is already set up to handle a normally closed or a normally open sensor. You have to get the right sensor for that situation, unless you want to go back in and rewrite your PLC program to accommodate the new sensor. So I hope this was useful. I'll do another one on inductive sensors next, and also we'll look at sensor specifications.